Mike here. Thank you for joining me. This video is about correcting flat earth goofy mistakes. And the question is this, and it's a real simple question without getting into too much complexity. Can the heliocentric model as given to us depict an accurate eclipse August 21st, 2017? And the answer to that is yes. Now we have some videos running around making all kinds of crazy claims. And to be honest, people, it just kind of makes us look bad. Now, Bob and Jared on Globebusters already did a video on this explaining that their model does work. I was supposed to join them, but I did not make it back in time to get in on that with them. But I think they did a fairly decent job. Now, some other flat earthers I've been posting to the last couple of days, and I explained to them, when they're telling me, well, NASA needs the Earth to spin the wrong way for it to even work, and when I tell them they're wrong, I get called shill and names. And so, thank you, Flat Earth community, for being ignorant and not hearing me out. I don't care either way. Whatever the case, if you're watching this on my channel, you will get the truth to the best of my ability, and I will explain to you what is going on. Mistake number one, a lot of flat earthers, and I've talked to several, claim that in order for Team Heliocentric to get the eclipse to work, the shadow running from west to east, they have to spin the Earth the wrong way. And here we have time and data, whose camera is fixed upon the moon itself, and it does appear that the Earth is spinning the wrong way. However, if you notice the shadows that start coming over South America, then that will tell you that the Earth is actually spinning the correct way. Otherwise, South America wouldn't start to get dark at the end here. And so when you have a camera fixed to the moon that's traveling 2,000 miles an hour and the Earth's only spinning 1,000 miles an hour, the moon is going to overtake the spin rate of the Earth, making the Earth appear to spin in a direction that it should not be spinning. However, folks, this animation is 100% correct according to the heliocentric model, and it works. So picture, if you will, the model I have done, the Earth rotating at 1,000 miles an hour the correct way, and the moon following the rotation of the Earth. The moon, moving faster than the speed of the Earth, will appear to make the Earth look as if it's rotating the wrong way if the camera is on the moon. Here is another representation of it. Pretend that the camera is the moon, and the moon is moving around Earth, and the Earth is spinning in the correct way. Since the moon is moving faster than the spin rate of the Earth, then the Earth will appear to rotate in the wrong direction from that perspective. So their model works as prescribed. Okay, this video is going around claiming that they need the Earth to spin the wrong way. I don't know who made this video. It's not from our space agencies, obviously. Maybe a 9-year-old kid did this who was playing with the modeling program. My point being is that we don't want to just grab any old thing somebody says and claim that this is what the heliocentric team is claiming to make their eclipse work. Folks, it's just bad practices, and it makes us look bad. We actually want to use their numbers and their data and not just grab any old thing that we think that works. Here's NASA's version of it. Now, I'll be honest here. I have no idea what NASA's thinking or doing. Their moon is stationary. Their light source is stationary. They have the Earth rotating. Apparently, they just pasted these shadows on top of the Earth as the Earth is spinning. NASA's model does not depict anything accurately. The moon actually should be moving towards the east, but we don't see that either. We see the moon lagging behind, which is not what Team Heliocentric claims is going to happen. So we would discount this also.
That's projecting the shadow. Here's an illustration of how that works. You have a light source, you have an object, in this case a sphere, and then you have a surface on which the shadow is cast. Now, if you notice, when the object isn't right up against the surface, the shadow is bigger than the object. We've all seen this, and we can duplicate it ourselves easily. You can use a quarter, a ping pong paddle, headlights of your car, and a garage door. You see it in the real world all the time. Look at this picture here. The sun has swung around to our region. The light is being cast over the peak of this mountain, and look at the shadow. The farther away it is, the wider it gets. because that is how it works in nature. That's what's duplicatable. That's what can be demonstrated. And this is, notice that the shadow is never smaller than the object. But explain this. This is supposedly an image from space of an eclipse over Mexico. And if you look at a map, you can see that's 50 or maybe 60 miles across. Hard to say, but it's not a quarter the size of the Earth. But could the moon cast a shadow smaller than itself? Look at this illustration. If the ball is right up against the surface, the shadow is the exact same size. And if it gets farther away, the edges might become blurry, and the shadow can actually be bigger than the object, but it can't be smaller. So how can you explain that something 250,000 miles away, a quarter the size of the Earth, casts a shadow 50 miles across right there?
So here we have a claim by a flat earther that an object can never leave a shadow smaller than itself. Here I've modeled a ball and put a light source directly behind it and set the ball in front of this wall. As you can see, as expected by the angle of the rays coming from the light, the shadow is a lot bigger than the ball itself. Now, if I move my light source back, see what happens. Notice the size of the shadow. It is a lot smaller than the ball, therefore proving that this flat earther probably needed to do his research a little bit more. And I'm not going to get too much into why this is. I actually moved the light back 10,000 miles, but it has to do with the angle of light rays and light bounce off an object at that distance, which he did not examine in his video. I grabbed this video off of David, and we're just all making observations, so thank you, David, for putting this up for us to examine. The thought here is, from this NASA video, is the moon takes 27 days to make one orbit around the Earth, and so if the moon takes that long to trek around the Earth, then there should be an eclipse of a total of 4 days on the Earth. This is what NASA's video is showing. However, NASA does not have this model to scale. The moon is too close. This is just demonstrating how the moon rotates around the Earth and not a demonstration of a solar eclipse. Here I've modeled the Earth and the moon to scale, the moon being 238,000 actual miles away, the moon being marked by a little green arrow sticking up at the top on the right-hand side, the Earth in the red and green crosshairs. In between that, I have a degree indicator set at 2.12. The moon travels 13 degrees around the Earth every day for 27 days to make one complete orbit. And the moon actually only has this little space of 2 degrees to leave a shadow on the Earth. Once it reaches outside of this line, the moon will no longer be able to cast a shadow based on its angle to the Earth and Sun. So here, once again, Team Heliocentric Model works. Now you might be wondering if there's anything that we can do to debunk their model by what they're showing us. Notice the size of the shadow over the United States stretching over Canada, reaching Alaska itself. That is what is suspect to me. Here's NASA's model. Now, even though NASA's model is broken, I think I can trust that they're putting the shadow where it's supposed to be because it also mimics time and date, so I have two sources agreeing with one another. So the question is, what would a shadow look like from the sun casting a shadow off the moon that is 93 million miles away and the moon 238,000 miles away? That's the question. And so I'm going to show you. So here you are. Here's a picture of the Earth with the shadow of the eclipse on the Earth right there by South America. That'll be the size and shape of a shadow left according to Team Heliocentric's model. Now you might be thinking, well, that looks like the Himmerari or maybe Epic's Discover picture of Earth. No, actually that is the Earth I made and modeled myself to see if A, there will actually be a shadow, and B, I wanted to see what the shadow would look like. Here I simplified the textures of the Earth, and you will see that the shadow on the United States is just a small dot not quite even covering half of it. This is nothing like Team Heliocentric is showing us, but this is the shadow according to their model and exact scale. So before I made my video, I've spent 3 weeks modeling this, checking all their facts, checking out where light is displayed, checking out other things concerning the heliocentric model with my to scale model. And that was to ensure that when I did make my video about the eclipse, it would be 100% correct to my best ability and knowledge, and that I would not be spreading any information that could be debunked by a globe earther. So one more time, zoomed in on the west coast, that's the size of your eclipse. Notice it looks nothing like what they're showing us with time and date or NASA's model. Supposedly this eclipse is supposed to overshadow most of the United States, and that certainly does not look like a shadow that's accomplishing what they're claiming to show. Now this is pretty significant because this is tied into some satellite pictures and other things that I have, and I am going to totally destroy Team Heliocentric's model in my next video. But for now, this video is just to correct some flat earth mistakes and just give you a taste of what's to come. This is Mike. I appreciate you watching. Please like and subscribe.